Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. All the candidates who are joining me, just quickly confirm whether my audio and visual quality, everything is clear. Now friends, for today's session I have one humble request for you. Actually, I have missed my pen and tablet. So today class, I will be trying to explain you a completed PPT. In the form of completed PPT, I will explain the concepts to you on a written PPT. I hope that is going to be okay for you, because at the end of the day, our intention is to understand the concept, understand the logic. That is more important. I hope it is clear for you. Now, before I start the session, let me say all the candidates who are joining me, quickly like the session, share this session with your friends and colleagues so that they can also revise it in the minimum time possible. And subscribe to this Gradeup channel if you have not subscribed till now. Friends, in this session, in this series of sessions, we are discussing the crux of important topics for your difficult subjects like electrical machines for coming GATE 2021 examination. Number of sessions I have already completed. They are available in the playlist of Gradeup GATE YouTube channel. You can watch them and you can learn or revise the concepts in a very less time. Today we are supposed to start single phase induction motor. Okay, I hope you all are okay with this and we can start the session. Now, before I start the session, some of you may be joining me for the first time. So there is a brief introduction about myself. My name is Ashutosh, as you can see on your screen. And this is my brief profile. And all the candidates who are live now, a very important information I want to tell you, that now you can interact with your favorite faculty directly by joining the Telegram group, Gradeup Telegram group, that is Gradeup EC and EE discussion. The link is going to be given in the description below this video. You can click on the link and that will take you towards the Telegram channel to finally join the discussion. Now friends, when we talk about the single phase induction motor, you all must be aware with that single phase induction motor is not self-starting. What is the reason why it is not self-starting? We'll discuss. But the problem is, if it is not self-starting, how we are going to start the motor? It means we require some speed control methods. The best idea what we are using right now for starting the single phase induction motor is that we know that three-phase motor is self-starting. Why? Because it has a rotating magnetic field. Similarly, a two-phase motor is also going to be self-starting because there is a rotating magnetic field. But when it comes to single-phase induction motor or single-phase motor, it it is not self-starting. Why? Because it does not have a rotating magnetic field. Rather, it is having a pulsating field, which we divide into two parts, that is forward field and backward field. That is a different idea that we will discuss in the later part of our discussion. But the basic idea, observation about the single phase induction motor is that it is going to be started as a two-phase motor. And when the motor is going to achieve near the rated speed, one winding is going to be opened or separated, and the motor is going to continue to rotate as a single phase induction motor. So you can say a single phase induction motor is going to behave as a two-phase motor at the time of starting, and during the running condition, when it is operated at rated speed, it is going to operate as a single phase induction motor. I hope you all are getting this. Now, when we talk about the starting of single phase induction motor, as we have already said, that we require a system in which a single phase motor is going to operate as a two-phase system. Now we have two possibilities. Either we can split the phase or we can split the pole. On the basis of this, there are two broad methods, split phase methods and split pole methods. In the split phase method, there are three main methods: resistance split or phase split, capacitor start, and third one is capacitor start and capacitor run. Let us first start with the split phase. And the first method is resistance split or phase split. What is the meaning of this? The meaning of this is that instead of using one single winding for the single phase induction motor, the stator is going to have two windings. One winding we are calling as main winding. This is the main winding. And obviously it is going to be highly reactive. Why it is highly reactive? Because this is going to provide the flux for the motor operation. So it has to be highly reactive, then only it is going to give you the required flux. One extra winding or auxiliary winding we are using, which we are calling as starting winding, and this winding is going to be highly resistive. Why it is highly resistive? And that is why we are calling it as resistance split. The reason is the starting torque of single phase induction motor is directly proportional to the phase angle between the main winding current and the starting winding current. So if your main winding is going to be highly reactive, naturally the current in the main winding is going to lag the applied voltage or the supply voltage by 90 degrees. So if the auxiliary winding is going to be highly resistive, then the angle between the main winding current and the starting winding current is going to be more high. So that sine alpha value, if alpha is that angle, is going to be more. Let us see this phasor diagram to understand it better. You can see that this is going to be the supply voltage phasor. Now this supply voltage phasor is being taken as a reference. As we have said that the main winding current is going to be highly reactive. So approximately this main winding current lagging angle is going to be close to 90 degree. Not exactly 90 degree because some resistance may be present. And if you see the starting winding current is lagging by a very small angle theta s, which is approximately 0. Why? Because we are taking the starting winding as highly resistive. Depending upon this nature of both the winding currents, whether it is main winding or starting winding, you can easily observe the nature of the wire and the number of turns you are going to use. For example, main winding. We are saying main winding is going to be highly reactive. It means its resistance is going to be very small. You know the resistance is given as rho L upon A, where L is the length of the wire and A is the cross-sectional area. So if the resistance has to be less, then cross-sectional area has to be more. It means for the main winding, we are going to use the thick wire. When it comes to let me just hide my image so that you can see the diagram on the screen. If you see the number of turns of the winding, they define the length of the wire. Naturally, more number of turns means more is the length of the conductor or the wire. And you know that inductance is directly proportional to the square of the number of turns. So if inductance has to be high for a highly reactive main winding, the number of turns should be more. Are you getting my point clear in your mind? So you can understand that main winding is going to have thick wire and it is going to have more number of turns. If you see the auxiliary winding or starting winding, its resistance should be high because it is a highly resistive winding. So the cross-sectional area of this starting winding conductor is going to be less. So it is thin wire. And because inductance has to be less, so less number of turns. Similar logic you can apply. As I have already told you that the starting torque of the single phase induction motor, it is very, very important to remember this formula. A lot of direct questions can be asked on the basis of this formula. The starting torque of the induction motor can be defined as being directly proportional to the main winding current and the starting winding current product, and sine alpha, where alpha is the angle between Im and Is. Im and Is. Now you can very obviously guess that if somebody gives you an opportunity to decide what should be the ideal or maximum value of this alpha, then you can say if we want the starting torque, then the starting torque must be high. Now the starting torque is going to be high when the sine alpha is going to be maximum. What is the maximum value of sine alpha? 90 degree. Sorry, 1. So alpha has to be 90 degree. And that is the reason why we are having the main winding as highly reactive and auxiliary winding as highly resistive. This is the reason. Now the same logic, number of questions can be asked. If you see the angle between the main winding current and the starting winding current, it is given as theta m minus theta s. You can see it from the phasor diagram. You can see it from the phasor diagram. Are you able to see this? What is alpha? Angle between Im and Is. What is theta m? Angle between Im and V. And this is theta s. So you can say alpha is going to be theta m minus theta s. You can write theta m and theta s in terms of tan inverse x by m. We are intentionally putting one external resistance here. What is the reason? What is the reason why we are putting external resistance? Please try to understand. You want that this angular displacement between Im and Is should be approximately 90 degree to get the maximum starting torque. Now this is going to be 90 degree only and only possible if there is some external resistance in the starting winding, and which is going to be of infinite value, or which is going to be very, very high, extremely high, which is not possible because Xm upon Rm will give you approximately 90 degree because it is highly reactive. Are you getting this? And this angle you want as 0. So you just put one external resistance in the starting winding and make it infinite, which is not possible. Are you getting this? Let me just hide my image again. Now if you see this diagram, this is the torque speed relation of resistance split method. Till this motor achieves 80% of the rated speed, it is going to operate as a two-phase motor. It means from starting to achieving the 80% of rated speed, the motor is operated as two-phase. The moment it achieves 80% of the rated speed, suddenly the auxiliary winding is opened by using the centrifugal switch. One switch is connected to the auxiliary winding, which we are calling as centrifugal switch, so that starting winding is disconnected. The moment starting winding is disconnected, there is a sudden jerk. There is a sudden jerk, and now the single phase operation starts. These are the applications and these are the ratings which is mentioned on your screen. You can note it down. Everybody okay with that? Can we go to the next method? Yes. The next method is capacitor start single phase induction motor. The first thing you have to understand why capacitor starts. You have seen that if you are using a highly resistive winding, whatever external resistance you put in the starting winding, you will never be able to have infinite resistance in the starting winding. And the angular displacement between the starting winding current or the main winding current will never be 90-degree achieved. This is only possible if you connect a capacitor in the starting winding so that the angular displacement between the main winding current and the starting winding current is approximately 90-degree. This is the reason we are having capacitor start motor. Let me again hide my motor. In this phasor diagram, you can say that again the supply voltage you are going to take as reference. Main winding current is lagging by some angle theta m, and starting winding current is now going to lead because it has the capacitor connected. So now you can very well achieve the 90-degree phase displacement condition. Again here also same thing we are doing. The moment motor reaches 80% of the rated speed, the two-phase operation is converted into single-phase operation so that auxiliary winding is open. This is the application and rating. Now same equation that we have written for the resistance split, you can write for the capacitor start also, and very good interesting questions can be made simply on this equation. And if you have the proper understanding that we are discussing, you will be able to directly write this equation, put the values, and you will get your answer. Everybody just tell me, are you getting this idea clear in your mind? Is it clear? Okay. Let me again hide my image. The third method that we wanted to discuss is capacitor start, capacitor run. Now in this capacitor start, capacitor run motor, there is no centrifugal switch in the first statement. It means the capacitor is permanently connected to the circuit, auxiliary winding or starting winding. Are you getting this? It means capacitor start and capacitor run motor where capacitance is permanently connected. It is actually a two-phase motor. It is not a single-phase motor. But just because we are using these method for starting a single-phase motor, that is why we are calling it single-phase. Otherwise, you can say both starting and running, the operation is two-phase. Are you getting my point clear in your mind? Now, along with this permanent capacitor, generally one more extra capacitor is used in parallel with this permanently connected capacitor to increase the starting torque. And this is how it is being connected, you can see. And that capacitor, which is generally connected during the starting to increase the starting torque, it is going to be opened as the motor reaches 80% of the rated speed. Now let us come to the second method, that is a split pole. Now a split pole method is basically shaded pole induction motor. Shaded pole induction motor simply says that if you see the stator, windings are not provided. Rather, the pole is splitted into two parts, one smaller part like this and one larger part like this. In the smaller part, either a shading coil or shading ring is used. Such a pole is called shaded pole. Same thing is being done for this pole also. Divided into two parts, smaller one and larger one. Smaller one you are putting some shading coil or ring. Now if you want to see how the flux is going to be established in the shaded pole motor, then you have to understand this logic. You are having a single phase supply, so the current is also going to be variable in terms of sinusoidal variation. Now you know the flux is developed because of the current, because current gives you MMF. Number of turns multiplied by current gives you MMF, and MMF establishes the flux in the core or the winding. Now the EMF induced by this flux is dependent upon the rate of change of flux. Are you getting this or not? And what is the nature of this EMF? From the Faraday's law or the Lenz's law, you can say the nature of induced EMF because of the rate of change of flux is to oppose its own cause. That is the Lenz's law. So this diagram, variation of flux for half cycle sinusoidal variation, shows you that there are three broad sections in the variation of flux: A to B, B to C, C to D. The variation A to B is that the rate of change of flux is more than 0, is positive. For B to C, the rate of change of flux is approximately 0 because flux is almost constant. And from C to D, the rate of change of flux is negative. Now the EMF induced is going to be such that during the AB section, it will try to oppose the flux because flux is having a positive rate of change. During the BC section, there is no opposition because there is no significant change in the flux. Flux is almost constant. And during the CD section, as the flux wants to reduce, the EMF will be established in such a way that during CD section, the EMF induced and the current in the shading coil will be such that it wants to increase the flux because it is opposing the flux. So when the flux is increasing, the current in the shading coil or the smaller portion of the pole is going to be such that the flux is going to be reduced or suppressed. BC section, no opposition. CD section, when the flux is reducing, the current in the shading coil will generate the flux in such a way so that the flux can be increased. Now you will very easily understand how the flux is established for a shaded pole motor. You see the AB section. During the AB section, the shading coil region or shaded pole region where shading coil or shading ring is placed, it is not allowing any flux. And all the flux lines are concentrated in the unshaded pole. Unshaded pole is the larger cross-sectional area of the pole where shading ring or shading coil is not placed. If you go to the BC section, because the flux is almost constant, there is no opposition, no EMF generated in the shading coil, no current. So flux is present in both unshaded and shaded region equally, equal distribution of flux. When you go to the CD section, if you go to the CD section, during the CD section, the flux wants to reduce. When the flux wants to reduce, the current in the shading coil or the EMF is going to be such that it will try to increase the flux because the flux wants to reduce and this shading coil wants to oppose that. So if something is reducing and you want to oppose that, it means you want to increase it. So majority of the flux is now going to be concentrated in the shaded pole region. What is the basic logic? The basic logic is for a shaded pole motor, even though the current or the supply which you are giving is sinusoidal, even though the flux is sinusoidal, but the flux is such established in the shaded and unshaded pole region that it looks like the rotor, that the flux is rotating from unshaded pole to the shaded pole because of this flux variation. I hope you are getting my point. And this is how the motor is going to start. But you can understand that this shaded pole motor is going to be used for a very, very small rating applications. For example, toys, small fans, etc. You are going to use these kind of starting methods. I hope you must be getting this idea clear in your mind. Now, as I was discussing why single phase induction motor is not self-starting, we have to understand that. We know that three-phase induction motor, there is a rotating magnetic field. Two-phase, again rotating magnetic field. Single phase, it is a pulsating magnetic field. And pulsating magnetic field can be divided into two fluxes rotating in the opposite direction as per the double field revolving theory. Okay, that derivation part you can see from any standard book or notes. Now, for this forward field and backward field, there are going to be two different fluxes established, two different torques, forward and backward, and the speed of rotor or the rotation is going to be nr and minus nr, because backward field means it is rotating in the backward direction or opposite direction. Depending upon two fields, there are two types of slips available for the single phase induction motor. The forward slip is the normal general slip, which we are calling as S, whereas the backward slip we are defining as 2 minus S. 2 minus S. Now, if you draw the torque and speed characteristic, if you draw the torque and speed characteristic, let me just hide my image. You will see that this is going to be for the forward torque. This is going to be for the forward torque. This is going to be for the backward torque. And this is going to be starting torque. And with this starting torque variation, you can very easily understand that during the starting, the torque is 0. And this is the reason, the pulsating field is the reason why the single phase induction motor is not self-starting. Now let us try to see the equivalent circuit of single phase induction motor. As we have said that the rotor of single phase induction motor is going to have two different responses, one for the forward field and one for the backward field. So what we will do, the equivalent circuit of the rotor side, that we are going to divide into two equal parts, and we are going to represent it in connected in series. For example, the core loss component RC, you are going to divide into two parts, RC by 2, because there are two fields, two fluxes. The magnetizing current component or the reactance XM by XM, we are going to divide into two parts, XM by 2 and XM by 2. Parallel to this, we are going to connect half of the rotor circuit resistance and reactance. For example, for the forward field, this is the forward field. For the forward field, it is going to be R2 dash upon 2S and X20 dash by 2. Similarly, for the backward field, backward torque is going to be generated, and it is going to be R2 dash upon 2, but now the slip has become 2 minus S, because here it is going to be backward slip. Similarly, the rotor leakage reactance X20 dash by 2 is going to be present. Now, generally what is happening, this RC component, core loss component, we generally club it together with the friction and windage losses. You can see it here. Friction and windage losses, core losses are going to be clubbed together, and total it is called as rotational losses, so that the circuit becomes little comfortable, little easy for calculation. Now, this forward rotor circuit and backward rotor circuit equivalent impedances we are calling as ZF and ZB. ZF is going to be the forward rotor circuit impedance, and ZB is going to be the backward rotor circuit impedance. Now, Z1 is R1X1, that is the rotor circuit resistance and reactance. So, very easily you can calculate the current drawn from the supply. This is the procedure, how you should proceed to the questions being asked in the single phase induction motor. Now, we want to know the power input to the forward rotor and power input to the backward rotor. As there are two, you can say, hypothetical rotors, even though it is mechanically constructed one rotor, but because of the two fields, two responses, we are having forward rotor and backward rotor. I square RF, I square RP. Now the air gap power which is given to the rotor is defined as PF minus PV. That is the forward rotor input and the backward rotor input difference. Now with this air gap power, you can write the output power or the mechanical power developed in the motor. That is going to be PMD is equal to 1 minus S PF minus PV, because you must be aware that mechanical power developed, you know, it is being written as 1 minus S in general, 1 minus S multiplied by PG, that is the air gap power. Air gap power we have calculated, power input to the forward rotor minus power input to the backward rotor. Now this mechanical power developed is going to be further divided into two parts, friction and windage losses. If core losses are also added, then it is going to be rotational losses. And after that, what is remaining is shaft or output power, which can be written as 1 minus S PF minus PB minus P rotational. You can understand P rotational is nothing but friction and windage losses along with core losses. So from here you can also find the efficiency, also P output upon P input. Now if you want to find what is the developed torque, simply air gap power PF minus PB you have to divide by omega S, that is 2 pi ns by 60. Useful torque you can find by keeping the shaft power, that is 1 minus F PF minus PB minus P rotational. I hope you all are getting this. So this is how we have completed the single phase induction motor, what I wanted for the today's discussion. But before we come to the conclusion part of this discussion, it is important to understand that most of the candidates, they are worried how you are going to prepare in these last 30-40 days for the gate examination. Now the Gradeup has opened the window for you till 30th of January. Till 30th of January, you can access the Gear Up and Rank Up Gate classes for 2021. But the best part is you don't need to have a separate subscription. It's one subscription that we are calling as Gradeup Super subscription will give you access to all the structured courses, and also the online mock tests are also available. For any further clarification, you can contact this number. These are the star faculties in the electrical department who are going to mentor you in the next preparation cycle. And most important is the Vision 2022. If you have not prepared well, if you have wasted a lot of hard and money of your parents and family, now it's time to take the right choice and right decision. Just one Gradeup Super subscription, you will be getting a complete preparation module with all the equipments. Whatever is required for your preparation, Gradeup is going to provide you. Okay, all the details you can ask in the below mentioned number and you will be assisted positively. My friend, this is the results we have produced over the years 18, 19 and 2020. 2020 has been a landmark year when 60 plus Gradeup students have topped in the under 100 rank. So friends, thank you so much from my side today. That is what I wanted to discuss with you. Stay connected to me in this series of sessions. We are going to discuss the important concepts of your subject electrical machines. And please like the session, share and subscribe so that maximum people can be benefited. And do not forget to join me in my next session. Thank you so much. Take care of yourself. Prep smart, score better. Go Gradeup. Thank you so much. Thank you. Thank you.